Okay, so once again you are most welcome. My name is Mtanda Samila. Now this time around we are in for item 014 and it is strictly coming from electrostatics. We are still continuing with our revision series of physics. Alright, good. So in here we're going to look at a lot of interesting stuffs, and of course let's move forward. Please remind you to subscribe to the channel, share this video to whoever may find it important, share to any person, because not everyone out there is able to receive the items together with their solutions. Alright, so consider sharing them to whoever may find them important, such that we can all benefit. Okay, so without wasting time, let's get there. Okay, so again we remind you to subscribe and hit the notification button such that you don't miss out. Hit the subscription button such that you don't miss out. Alright, good. So without wasting time, please share, like, and also leave a comment, or you can just give a thumb. Hit a like button and just leave it. That takes only 1 second, hitting the like button only. Alright, good. Now with that, let's go straight to the question. Alright, good. There we are. Let's go through it slowly. So they're saying, during an evening downpour, so please, downpour means rainfall, a sharp flash coupled with a loud sound were witnessed. As a result, the whole village experienced a total blackout. Oh, that's really bad. Later it was discovered that a transformer had been damaged by the sharp flash. The village organized a meeting to solicit funds to purchase a new transformer. Oh, it's a bit expensive. Hope you got the money enough for it. In attendance was an area member of parliament, MP, who promised the members that he was to purchase a device which can safeguard the transformer against other damages from such a flash. Alright, good. Now, as you are reading, you must be figuring out what do you think the flash is and which device can control that flash. Of course, in your mind, you should be having it that we are in for lightning and a lightning conductor itself. Good. People wondered how the device can protect the transformer. After 2 weeks, the funds were raised and a committee was selected to go to town and buy the new transformer. Alright, good. The transformer dealer presented to the committee a transformer which supplies a 12 volts when connected to a 240 volts main supply, and it takes current of 1.1 ampere from the mains. When used to light, it takes current of 1.1 ampere from the mains when used to light 10 12V 24 watt lamps in parallel. Alright, good. Alright, good. So without wasting time, let's go and proceed to another part. Okay, let's finish up our question very fast and we see the way forward. Okay, so now with this they are saying, let's pick our laser pen again. Okay, good. They're saying the dealer convinced the buyers that the transformer had an efficiency of at least 96%. By the way, remember that the efficiency of the machine is always the 100%. So if it's 96, then it's super good. Just know that. Okay, they were not sure of how the dealer arrived to that value. Oh, that's really bad. Okay, so using the knowledge of physics, right? Part A, find out whether the trader was trustworthy when he stated the above value. Oh. Part B, sensitize the community on how the device would guard the transformer against such destruction. Alright, now let's go into that. So we start off with this. Now they want us to find out, find out whether the trader was trustworthy. Now, what the trader would be trustworthy if we calculate the efficiency of a transformer. If it comes to 96% or 97%, then we shall say is trustworthy. But if it is below this value, then we shall say it's not trustworthy. Now with this, let's still go back and pick the details enough to get this done. Now, we shall of course specify. Now you all know that to get efficiency equals to you all know the formula is the power, all right, the efficiency is equal to the power output over power input. Hope that is clear, times what? 100. That's what we have. Now it means that in this story we need the power output and the power input, but of course allow me use a table here, a simple table like this, whereby in this table, please, in this table I want to strictly use this one here. Allow me use this as power input, and this one here is power output. That's what happened here now. But remember, power is equal to the current I times the voltage. Now let's also go and learn, if this is our transformer, for example, imagine this is our transformer here, right there. Maybe this is our transformer right here. Please, in the playlist you have very many questions about a transformer, how it works, step down and step up. You can visit the playlist and look for under UCE physics revision items. You can check there, you will see very many scenarios. We are on the item 014, but we have right there from item 001. So better check and enjoy. All right, good. So this, let's speak. Now what you should know is that now once a transformer is receiving, we call that an what? Input. Once a transformer is giving out, that's what we call an output. And guess what it's giving out? Now the transformer gives out to the electricity to homes. Okay, it gives out electricity to homes. Okay, good. Now what must we know is, let's read that part of the transformer. They say the transformer dealer, we start from here. The transformer dealer presented the committee a transformer which supplies 12 volts. So supplying it supplies 12 volts. Okay, good. It supplies 12 volts. Good. Let's continue. When connected to a 240 V mains. So when connected to a 240 V mains, meaning that when this transformer was connected to a 240 V mains, so was connected to a 240 volt mains. Now that is the input. So it means that in the input, the PD there is equal to a 240 volts. Okay, good. Let's proceed. Main supply, and it takes current of 1.1 ampere. So the current takes, meaning that the transformer also takes current of 1.1 ampere. So it means that there the current I in the input is as good as 1.1 ampere. Now with this, we can calculate our power. So from power is equal to IV. So our power will be equal to a 240 times a 1.1. So our power there will be equal to, in simple terms, 264 watts. That is the power we have. Okay, good. Now about this side, they're saying, so when it takes a current of 1.1 ampere from the mains, when used to light 10, 12 V and 24 watts lamps. Now here, if you look at watts means power, so we have power here. So but remember there are 10. So if there are 10, total power consumed will be a 10 times 24. So therefore here total power consumed will be a 10, in fact a 10, which is 4, right? So a 10 times a 24, like that. And how much shall we get as the total power there? So total power is equal to, of course, multiply 24 times 10. So total power equals to, okay, so here it means that the power will be equal to a 240 watts, like that. But remember, is that efficiency is equal to power output over power input. So that will be that our efficiency will be equal to our power output is how much? Power output is 240 divided by our power input, which is 264, and the whole thing times 100. Now the percentage you shall get here shall compare with the 96 which the seller had gotten, and then we see if he was trustworthy or not. And I think with that, let's go and answer part A. So that is our part A. We're going to answer part A very fast. Let's go there. So let's move there. So realize that in the long run, we're going to have that efficiency is equal to power output over power input times 100. So in the next part, you shall get that, but from power input is equal to IV. Of course, that's formula for power, but we're calculating the power input. But remember, our I was 1.1, and our V is 240 volts. So power is equal to, we multiply. In fact, you realize that here, this is here is the I, this one here is the V, and you have them right here, and you have them right there. So in multiply, you get 264 volts, and with that, we've got the power input. Now that we want power output, so you shall say that power output also would be IV. But remember, the transformer lights 10 bulbs each of 12 V and 240 and 24 watts. So therefore, we have the power already consumed for one lamp. What about when there are 10 of them? We shall now say that total power output is equal to 24 times 10, and that will give us 240 watts. Then again, still, we shall remind you of the formula of efficiency, which is equal to power output over power input, okay, times again 100. So next, we're just going to do the substitutions, and so realize that the 240 is done have up right there. Sorry, where is this off? So the 240 is done have up right there. The 264 power output is done have right there. Next, use a calculator to press. You realize that you get a 90.9%. Oh, by the way, remember the other seller told them, in fact, I would say deceived them, that the efficiency is 96%. Then they ask, is he trustworthy? Now look at this and that. It is by far less. So it means that the seller was not trustworthy. And with that, let's conclude and say, shall I conclude and say, alright, good. Okay, so he's saying he was not trustworthy, by the way, since the efficiency of the transformer is 90.9%, yet for him he stated at least 96%. So the seller wasn't trustworthy. I hope you don't be like that seller there, because I know it's not good by that to be deceived. Alright, good. And with that, let's go and see the next part. Now part A has been successfully answered. Let's see the next part. Part B, the sink. Part B, the sink. Sensitize the community on how the device was a lightning conductor. I talked on that. Lightning conductor was the device. The device was lightning conductor. Would guard the transformer against such destruction. Now here they want the mode of operation of a lightning conductor. And without wasting time, let's get there. Okay, good. We shall get it ready there. Maybe first of all get the writing, and then shall come on later. Okay, good. So, okay, maybe let's first get it in little explanations, then we move on. Now, alright, you realize that the mode of operation of a lightning conductor starts with this guy here. Alright, like that. Now, there's something which you must know here. There's something which you call charge density. And I'll explain this. There's something which you call charge density. And now charge density in simple terms means, if I have, say for example, an object like this. In fact, charge density, if I have, say for example, an object like this is a sharp point, then another object is flat like this. Remember, this is object A, so here is object B. Now, you find that these sharp points here, it is said that these sharp points here have very many charges. Every sharp point has got very many charges. Every sharp point has got very many charges. So that is A. Now in B, it can have, if it is flat, you can have a charge there, a charge there, and a charge there. Now guess what? Here they are like around 10 charges, but here they are around 3, meaning that once the surface is flat, it has a few charges. Once the surface is sharp, it has very many charges. So it means that these spikes you're seeing here, they have very many charges. Very many. That's why they are made to be sharp. That's why these points are made to be sharp, in order to have very many charges on them. That is it. And now these are the spikes, and the whole process starts from this guy here, seeing there. And that's how this part of the lightning conductor, these are the sharp spikes. Now, it goes with they have what you call a high charge density on their spikes. Now this charge density here helps in what we call ionizing. I'll be explaining that. Now let's move to the next step and get this in details. So there we start off. Now that's how lightning comes about. That's how lightning comes about in that picture you're seeing there. Now in the next picture you're going to see. Okay, now those are the sharp spikes we have right there. Okay, maybe we just get it at once like that. So you realize that we have now, these are the sharp spikes I explained. Remember, they have a million of positive and negative charges here. A million of positive and negative charges. A million of positive and negative charges. A million of positive. That's how the story begins, first of all. That's how the story begins. Both positive and negative charges. Both positive and negative charges mean that is neutral originally. Now what happens is, what if when a negatively charged cloud. Now a negative charged cloud can be just the simple rainfall when it is raining. Of course, one would ask, how can a cloud come near the house? No, we mean just the rainfall may come along with very many negative charges. Of course, where do those negative charges come from? When two clouds rub one another due to friction, one cloud is positively charged and one cloud is negatively charged. Now, the negatively charged comes on Earth, the positively charged goes up. So, this one here, the negatively charged, which comes as a result of friction, comes and moves nearer to, remember, you'll be having your house, and on top you have what you call a lightning conductor. So, the cloud comes around there. That's what we're talking about. Now, this lightning conductor here is connected to what you call a copper wire downwards this side. This one here is a copper wire or a copper plate. It is a copper plate. This copper plate goes up the earth or inside the soil. That's what I'm meaning. Now, once a negatively charged cloud comes here, it means that, remember, when you have a body like this and you bring, say for example, a negative charge nearby, if this body has positive and negative charge, find that the positives will be near here and the negatives will be repelled away. If you can see that, it means that here, like charges do what? Repel. Here it's saying that like charges repel, meaning that negative and negative, they will repel, positive and positive, they will repel. So, when negative charge cloud comes here, what do you think is going to happen? What happens here is that this is the negatively charged cloud right here. Now, what it comes here, just remember, originally we have both negatives and the positives. So, once the negative charged cloud will come, remember, assuming this is the negative, so it will not allow the fellow negatives to be there. So, the fellow negatives will run away downwards through this copper plate. And you can really see that they are flowing here, and you have that negative there, you have that negative there, that negative there, flowing through the copper plate safely downwards. Now, one would ask, why do we use copper? Because copper is a very good conductor of electricity. By the way, even back in the 90s, the electric poles you see of today, the electric wires you see there were once copper wires. They used to use copper wires back then, but just because copper wires are very expensive, the natives could go ahead and cut down electric poles and pick away the copper wires for sale. And with that, the electricity board chose to start using aluminium, which of course has market, but not all that. Okay, so that has been just as by the way. So that's why here they use the copper plate, because it's a very good conductor. It can safely conduct the negative charges downwards. So in this story, what you should know, only negative charges flow downwards. How? Because negative charges have been repelled by the fellow negatives, from the rule that like charges repel and unlike charges attract. So in the so doing, as they're flowing down to earth, now we no longer have a negative here, we no longer have a negative there. So guess what? But remember here, in this area here, we have what we call air, surrounding air. But this air has got both positive and negatives, scattered in a disorganized way, both positives and negatives, Now, it is in a confused way, and therefore this air here, it is neutral at that moment. Now, what you should know is that after the clouds have repelled the negatives away, these positives which are remained here, on the spikes, what they are going to do, remember, there are very many. What you should know here, we can have around 1 million positive values, charges, and on the cloud maybe have only 1,000. negative charges. And for this battle to be completed, we must make sure that these negatives, they are all nowhere to be seen. It's more like a war. Now what happens here is that these positives here, which are around 1 million, they will go ahead and repel. They will go ahead and repel. In fact, what you should know is that now what they will do is, remember this air is like this, so what these positives here will do, they will go ahead and repel. In fact, since they are positives here, they will attract the negatives near to them, like you're seeing in this picture, the negatives near to them, and now they will chase away the positives. But any positive which goes up, once it finds a fellow positive, it pushes it further. Once it finds another positive, it repels it. Once it finds another positive, it repels it. So just know that upwards, from the spikes upwards, all we are having up, the only charges which are going up are only positive charges. And these positive charges, they're moving up now. Now we find the cloud. Now every positive charge dies out with a negative charge. Every positive charge dies out with a negative charge. Every positive charge has gone up dies out with a negative charge. Remember I told you that here we have around 1 million positive charges and the cloud has only 1,000. It is counterbalanced though. So it means that every positive charge which goes in the air dies with a negative in the cloud. Every positive charge dies with a negative in the cloud. So it means that now the cloud has no charges finally. I hope you see that. The cloud has no charges finally. And if it so happens that there is an excess, these negative charges can be attracted onto the spikes, onto the what? Onto the sharp points, the spikes there, and either that negative charge can also die with the positives around here, or it can smoothly flow to the earth in the copper plate downwards to the earth. Now one would ask, why does it flow to the earth? Please, the earth is considered to be at what we call zero potential. The earth is always at zero potential. Zero potential means that it can absorb any amount of charges and can as well give out any amount of charges. So the earth can both absorb or give out. That's why we put the copper plate into underground. So whether it brings 1,000 ampere current of 1,000 ampere or 10,000, the earth will absorb it. Whether 1 million ampere, the earth absorbs it and remain unchanged. That's why we call it, it is considered to be at zero potential. Now at this point, the cloud has no negatives, and therefore the cloud is harmless. And with that, we shall say that the lightning conductor will have protected the house. You see that the negative charges are still flowing to the earth, and the whole story ends there. And that's how the lightning conductor works. However, still, that has been pictorial. Let's go and see it in the writing. In fact, maybe just to explain the ionization here somehow, because someone may not understand me. What I mean by ionization, just imagine this is the copper. In fact, the spikes. Remember, around here you have positive charges, and what you have here is all air. What you have here is air. Now, what happens is this air, that air you're seeing, let me just bring it in the sidewalk here. What you're seeing in the air there is both positive and negative. Negative, positive, negative, 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 positive, positive in a disorganized manner. So this is the air we are having. But now we need to ionize it. To ionize means that the positive will be on one side and the negative will be on the other side. So since this one is positively charged, in here it will attract the negatives to itself. They will attract. So if they attract, it means that we are going to have negatives aligned near here and the positives chased away this side. Chased away this side. But remember, as they're doing that, this has been air at level 1. But remember also, but now this is where our clouds are. This is where our clouds are with the negative charges. Now remember, this ionization continues, like we have explained. So again, these positives here will attract negatives near to them, and then positives are away, like that. You see, like that. Now again, it continues. Maybe this the air near the clouds here, the negatives will be attracted nearer to the positives, and the positives will be repelled away. Now every positive here dies with a negative. Every positive dies with a negative. Every positive dies with a negative. Every positive dies with a negative. That's what we call neutralize. That's what we call neutralizing in simple terms. I hope that will make some sense. Anyway, right, let's go and see that in writing straight away without wasting time. Okay, good. So let's see that in writing. Let's see that in writing. So you're saying that when a negatively charged cloud, we are getting this explained. So we are saying that, alright, good. We are saying that when a negatively charged cloud passes over, I explain this, when a negatively charged cloud passes over spikes of a lightning conductor, those are sharp points, a positive charge is induced on the spikes. A positive charge is induced on the spikes, and the negative charges on the earth plate. Now earth plate, like I showed you, when they're flowing downwards. Okay, since the spikes have sharp points, okay, spikes experience a high charge concentration. Now this is what I was calling my charge density. I explained that. This is what I was calling my charge. Okay, this is what I was calling my charge density in simple terms. High density, I explained that, which create a strong electric field. Now strong electric field is one which brings about what we call a strong electric field. Is done. I was telling that positive charges are 1 million, while the negative charges are 1,000 on the cloud. So it means that the positive charges are very many because they are sharp points. As a result, the air molecules around the spikes are ionized into positive and negative ions. I explained this ionization here, where the positive continues to, okay, chase out the fellow positives and attract the negatives near to them. Okay, the positive ions are repelled towards the negatively charged clouds. I explained that, where they neutralize some charges on the cloud. Good. The negative ions attracted to the spikes, where they neutralize some charges on the spikes. Okay, a discharge from the cloud is safely conducted to the earth through the thick copper strip. So that's what I was saying, telling you that it will flow through the copper wire down to the earth, because the earth is at zero potential, it can absorb any amount of charges. So this leaves the cloud with no charge and it becomes harmless. Now maybe I want to explain this point here, where if, say for example, we have our cloud like this and has negative charges, if it so happens that after ionization some charges remain, remember here I have positives, these positives are going to attract the negatives to them like this. Now once the negatives come, some of the negatives can kill or neutralize the positives on the spikes. If the negatives are still very many, then they will flow towards via the copper plate down to the earth. That's what I mean here. Erase this off. Okay, good. I hope that will make some sense. I would beg we end at least here. It has been at least a nice one to, okay, a nice lesson you need to learn from, because lightning is something of everyday life right now, and you all know how deadly it is. How I wish you can secure a lightning conductor at your home premises or even a school, such that the incidences or catastrophes which come as a result of lightning, you are safe from them. Please, as our usual way of doing things, at the end of this video there will be another pop-up. Maybe you'll be there to watch it. Thank you. Have a nice time. Have a nice day.